Okay, we're back. We'll pick up where I left off here, which was on the SRB recommendation from June to conduct a sensitivity analysis of the 4 stock assessment models using comparing a normal to the log normal prior that I've been using. And I also included a uniform as well, with the notion that the normal prior could be, in some circumstances, the normal prior could be less informative. Let's get to my next slide. Okay, so these are scaled independently just so that you can see them. So don't try to do the integral. But these are the 3 priors that were compared. The log normal, recall, is based on the longevity meta-analysis that Owen Hamel and Jason Cope have published 2 or 3 times now, which is just basically the expectation of your natural mortality as a function of your longevity of your fish. And the meta-analysis dictates the spread of that log normal distribution. So the blue one is based on that meta-analysis. For the normal, I used a normal with the same expectation and the same 95th percentile. And you can see, as you all noted in June, that there's more probability in the tail here than you would get from a log normal. So in that regard, over some range, it's less informative.
The normal's just truncated here.
And I truncated them all at value of, I think, 0.03 for this analysis. And I actually ran that when I ran the stock assessment models, I bounded them at 0.25 on the high side, just to keep it in a plausible range for Pacific halibut. And so, as you can see, this is the short coastwide model. Both you can't see it really underneath, but the normal and the uniform both just go to the upper bound and get stuck. And this is exactly the same thing that happened with when I used the log normal prior for this short coastwide model. And that's why this short coastwide model, we have an estimated M. You can see that at a value of 0.25, it's essentially double the biomass, with a similar but slightly more exaggerated trend as recruitments are larger and move through a little bit more quickly. So I plotted it here, but it's really not a statistical result because it is stuck to the upper bound at 0.25. The other models, however, where we were already estimating M, were largely insensitive to the shape of the prior. So this is comparing the 3, the base prior, which was the log normal longevity based prior, the normal in black, and the uniform prior in red. And you can see the uniform prior does allow M to go slightly higher in the short areas as Fleet's model, but effectively the same result. Similarly, for the long coastwide model, you can see at the peak biomass there in the late 1990s with the uniform prior and it creates a slightly higher natural mortality. So there is definitely some constraint being provided by either the log normal or the normal that is there with the uniform. But generally, for the other 3 models, the data are what are largely driving our estimates of natural mortality. Similarly, for the so I do think that the log normal prior, just because it's based on a meta-analysis, is probably more defensible. But it's these 3 models are not terribly sensitive to the shape of the prior. We'll continue to explore the short coastwide model. Someday, maybe not me, but somebody will have enough data to estimate M with that model.
So where does M end up on these other 3?
Between 0.17 or 0.18 and 0.21.
And why did you set it up for the short areas?
Yes. So recall some of our discussions from the 2022 full assessment. Historically, there was a value of 0.2 used, and then in the late 1990s, there was a change to use 0.15 at a time when the stock was increasing rapidly. It seemed like a good idea to be more precautionary. And we just have not come up with a rationale to change that assumption. The longevity-based prior, I'll point out, gives you a value slightly less than 0.1. So we are in the upper tail of this, but halibut are not your standard fish. They also continue to grow throughout their lifetime. So I guess we have not had a strong rationale for replacing 0.15 with a different value. We talked 3 years ago, we talked about using something that was more like the central tendency of the other three. But effectively, this model is serving as our lower bound on, I think, productivity.
Thanks, I forgot the discussion 3 years ago.
Yeah, it's a challenging one. I would love to replace that with something that was based on the data that we have at hand, but or at least more substantially updated by the data. But
So they come out with different M's though. Each of the different.
these do come out with a slightly different M. Yeah,
Does that affect like relative spawning biomass? Or those things or?
not much. This would be the model that has the largest effect, and you can see with a uniform prior, you're getting just a slightly higher M. So the biomass is larger, and the stock would be slightly less depleted. The M, and because of the way growth is nearly linear for halibut, higher M means higher biomass. It scales almost perfectly. There's a sensitivity from June showing the coast-wide short model, and the 3 values of M is just a linear relationship to the size of the spawning. So for the time being, I think that's about it for M. This next one was actually a really interesting request. It's something that I had looked into a few years ago on the request of the commission, and then you all refreshed this request in June. So this was to look at the historical performance of the decision table, essentially to do a retrospective of how management advice had changed over time. And it's a little more challenging than it seems at face value, because we're providing a probabilistic estimate. We're giving a probability that the stock is going to increase or decrease in any particular time. And so, unless you said the probability is 0, you're not wrong. You're just trying to see whether you're getting a series. I think whether you're getting a series of improbable events or not, based on the estimated probabilities. So, to show you the data first, the 2 key management metrics, and I chose 2 because one, I could recreate these in all the decision tables all the way back to 2013. And 2, these seem to have been the main focus of the commission in the last few years when they're making decisions. What they really want to know is, what's the chance the stock's going to go down? And if it's going to go down, what's the chance it's going to go down by at least 5%? So that's maybe a meaningful change. And so these are the data here. On the right-hand column is the estimate from the current stock assessment of what actually happened in each of these decision years. So you can see we don't have a lot of contrast. It's not like the stock has gone up and down by a large amount in each of these years. We do have 2 years, well, actually 4 years where the stock changed by at least 5%, but it was only between 5 and 8% down in those years. So what I've color coded here, these are at the time, based on the stock assessment projecting forward into the next year. So the decision year 2013 is based on the 2012 stock assessment, saying, okay, next year, if you take this catch, this is the probability the stock's going to go down, and this is the probability it's going to go down by at least 5%, based on the catch limits that were adopted at that time. So what I've highlighted in bold here, or bolded, are the right answer, effectively. So these are the years when the stock did decline, and these years in bold are the years when the stock did decline by at least 5%.
You can't really see.
Oh, I'm sorry, you can't see me. Yeah, okay. Hand. Yeah. Hold it?
Okay.
Great. Okay. Sorry, my bad. So these bolded values here correspond to the years in which the stock did decline. So these probabilities are the actual outcome, effectively, as we understand it today. And these are the years bolded where the stock did decline by greater than or equal to 5%. And so that would be these years here that I've shown in bold. So it's down 5%, 5%, 8%, 7, and 5. So those are the data that went into this. Then I tried to come up with a way to plot this, and I probably spent 2 days trying to figure out how to make a graphic out of this that would show you something. So you may not like this at all, but this is what I came up with. So for each decision year across the bottom here, each of these columns adds up to 100%. And the part of the column that's above 0 would be, for this graph, the probability that the stock is going to increase over that year. Probability that's down below would be the probability that the stock's going to decrease in that year. And the color coding is green is what actually happened in retrospect, and red is the wrong answer, effectively. So the way to interpret this is, for example, in 2013, we had, and I'll go back here to give you the actual value, we only had a 16% chance that the stock was going to increase. But we think that in retrospect, we think it actually did increase in that year. The probability that the stock was going to increase went up in each of the next 2 stock assessments. And in fact, the stock was increasing over that time period. Then the stock decreased in 2016, but we still estimated a fairly high probability that it was going to increase.
What are you pointing at now? Which ones are you talking about?
I hate this. They do me. Sorry. So here, this is 2016. Oh, there's a great delay too. I'm not even going to try to use the cursor. Sorry. We'll just get rid of that. So in 2016, you can see there's a pretty large red bar above the line, and that corresponds to a pretty high probability estimated at the time that the stock was going to decrease for another year. Was going to increase for another year. But in fact, no, I got it backwards. Jeez. Let me go back one.
So
Let's look at
above
the
the horizontal
probabilities
line is the probability of increase. Or it's just increase. Everything above the line is increase. Everything below the line is decrease. And then you're just moving the bar to see what the bar, where the bar is located, is what the projection said was going to happen. And the colors are what actually happened.
Yes.
So if this was doing really well, you'd see a lot more green than red.
If you predicted exactly with 100% probability the right outcome every year, everything would be green. So the red is the parts of the probability that were in a space that didn't happen.
So it's not like you can't compare probabilities directly, but you could say if probability of, say, a decrease is greater than 50%, you want those to tend to be green.
And my read on this is that we tend to lag a little bit. So the stock was going up, and it took a couple of years to catch up to predicting that. And then the stock started going down. And although we had a reasonable chance it was going down, it took a couple of years to be really sure that it was going down. And then similarly coming back up again. The stock increased for a couple of years, and it took us a couple of years to pick up that increase. And of course, we don't know 2025 yet.
So 1 year, or how many year projections?
We only make 1 year projections. Well, we make 3 year projections, but there's only one that's being used because they make a new decision now. So this is the probability of stock increase or decrease, and then this is the probability of stock decline of greater than or equal to 5%. So the 0, and this is where it's confusing, because the 0 here is at least 5% down. But you interpret this exactly the same way. So basically, we didn't think there was any chance of the stock going down in these by at least 5% in these first assessments, and we were right. And then it did go down by 5%, and we didn't have a huge probability on that, but those probabilities went up as it went down for a couple of years and then back the other direction. I will say this year in 2020, the year that it went down the most, it only went down by 8%. So we're talking about a pretty small slice.
Yeah, because cumulatively, it's 5, 7, 8.
Yeah.
That that's the trouble with 1 year ahead projections. You're dealing with small numbers and everybody's like, it's just fine.
Absolutely.
Look back at it, it's like,
Yep.
yeah, it's been 5% for 5 years in a row.
Right. So we were,
But by 2020, you had a pretty good probability. You were saying it's probably going
exactly.
to. So you,
And even
Yeah,
in,
right.
even in 2019, we had a 1 out of 3 chance. It's gonna go down.
So 1 out of 3 chance, declining by at least 5% should generate a response.
And it did. They were reducing the quotas during that time period. Yeah. But my takeaway on this is that generally we are underestimating the probability of declines to some degree,
Given the quotas that they're choosing.
given the quotas that they're choosing.
So
Yep.
they did make a response, but it still declined by that much.
Yes.
So
So these are the quotas that they actually selected. So you'd say this should elicit a response, but this was the response. So in 2020, for example, they chose a quota that had greater than 50% chance of further stock.
of
at
greater
least
than
5%.
decline.
Yeah.
So it makes you wonder what the objectives are.
I think you could show this with receiver operating characteristic curves.
Okay.
If you've got a probability and then you've got a binary outcome.
I'll have to look those up. I'm not familiar with receiver operating curves.
That will tell you sort of whether this is better than chance.
The, if we had a large sample size, we could just compare the distribution, right? The expected and the observed should be uniform, right? Relationship between the two. So that would be another way to do it. But I felt like with this few data points, that was necessarily very helpful.
This is, you could look at the presence absence. That's with the receiver operating curve. You're gonna have, you have to choose a probability ahead of, well, that's the way they use them. Choose a probability ahead of time to say whether it's present or absent. So they don't always use 50%. So if you build like a species distribution map, it's going to give you the probability of presence. Right? Then you say, okay, well, what is the habitat? And it's not necessarily wherever the probability is greater than 50%. Usually it's a number less than that, that the, whoever they are, the NPA people and all them, try to use, and they use the receiver operator curve to say, okay, we chose 30% as being threshold. How often would you correctly assign? Practice, how often?
Yeah, the idea is that you might, your probabilities might be scaled wrong,
Yep.
but there could still be information
Yeah.
there.
Sure.
So this says like across a wide range of what we're going to call threshold for saying it's going to go up or it's going to go down. How well does that outcome change? How much does that outcome change in response to changing probabilities?
Yeah.
And
So
ideally, your probabilities would actually be accurate probabilities, but they might still be useful even if they're not accurate, but they are responsive to the outcome, right? I mean, the outcome could be much more common than your probabilities suggest. But if your probabilities are going up, the right outcome is more common.
This one, I just eyeballing this is pretty close to having equal area above.
Yeah,
Line.
exactly.
So
And
this one's not going to be too bad. This one is where I think we're underestimating the amount of decline. But that's essentially that's what you're doing. You're going to sum this up and see whether you have your cumulative probability of being above or below your target is. If you're see whether your estimates are putting equal probability of being above below where you think you are.
Yeah, and these ROC curves will have a diagonal line, which is the sort of random chance
Right.
line. And so it's sort of how much area is above that line. Yeah.
Mhm.
This will be tough to explain to a non
Yeah.
SRB.
It certainly will.
But It's,
Yeah, I think
it does reveal some, like, if you think about it, it kind of reveals that, well, it should reveal the kind of implicit objectives, or at least see if they're consistent. Well, you don't have repeatability, the same scenarios happening over and over, but
I mean, one way, I know this is not the advice that you're giving the commission, but one way to look at it would be instead to say, what is the actual quantitative projection? Well, I'm not seeing it. That's right. And then what was the next assessments?
But that discounts the uncertainty.
It does, but it's not how the advice is being given.
Right.
But it's I think, a much more intuitive way of evaluating the performance.
So
At
we,
least the performance of the mean projection, right? Not the uncertainty, but
we have had the discussion has come up, which is basically if we're standing on the side of the highway and I tell you you have a 90% chance of getting hit by a car if you try to get across the highway, and you run across the highway and look back at me and say, "You're wrong, because I made it." I wasn't necessarily wrong, right? We can have some of these cases where there's a relatively low probability of event occurred. And so especially here, that's partly what I think is going on with this lag here, is that we don't have the information yet to see the probability of the event that's unfolding. And then as we gain more information, we dial that probability in. It wasn't implausible to begin with, but it becomes more plausible as the data catch up and start to show us what's.
yeah, it's just, it's an inherent property of stock assessments. They lag.
Right.
And they lag in the wrong direction. When the stock is going down, if you look at the history, my definition, if it's going down, biomass and apparent productivity has been larger before than it has. So it hasn't seen how low it can go. So it's always slightly above, and the same thing going the other direction. So it'd be interesting to try to find a way to summarize what you learn from this. You could communicate in the decision process. Is like, stock is going down. This, we did a retrospective analysis, and it tends to show that the probabilities I'm showing you are probably underestimates. We don't know how much, but in the past, if this model says it's a 30% chance of a decline.
Well, I don't think we're too bad in terms of decline, but here I think probably that's the case. That if we're estimating,
Oh, this one, yeah, this is the
yeah,
one.
if we're estimating a chance of 5% decline, it's probably a greater chance than what we're estimating. Because the cumulative probability of these 5 years here is still not that big. See, 5 years in a row.
Which ones? Which one again? The middle ones?
Yeah, the middle
Oh,
5 there where it's green. So the 2020 was the 1 year that we said there was greater than a 50% chance that outcome would occur, and it did. But it happened 5 times in a row there, that the stock went down by at least 5%.
Right, but if you're, so you take your analogy and you turn it around and say, okay, you're gonna stand on the side of the road and say, you've got a 25% chance of making it across that road. I don't know if I'd do it. It probably, that's a pretty serious chance.
Well, but having a stock decline of 5%,
Greater than 5%.
greater than 5%, isn't the same thing as
It's not,
hit by
but
a car.
like I said, it's, these are a death by 1,000 cuts, right? If you accept that you're willing to live with a greater than 5% decline at 25% probability, and you keep doing that, you're going down pretty fast, actually. I mean, 5%, what's the production rate? It's
It's not a lot different than 5%
yeah, so
on a year-on-year basis.
and you get down to a point where it's like, okay, now you're convinced you're going down, and it doesn't show the magnitudes. It's just greater than 5%, but I mean, it's like 8%.
So there's two levels here, I think. There's how accurate the probabilistic forecasts are. And then there's the decision making. What level
Yeah.
of risk was accepted in a particular.
And I think what we were trying to get at with this request is to try to start to sort those out, like how much.
Yeah.
You know, is it that you're providing information that's inconsistent from year to year and they've learned to distrust it or something like that? Or is it, no, you're providing actually pretty decent estimates of these things. It's not your issue. It's a choice issue. So,
Can I show some, I don't know the best way to show this, but this is sort of what I had been thinking of, not knowing about the whole probabilistic nature of the advice. This is for black sea bass on the East US, but the red here is the projections. They do multi-year projections. Black is the most recent stock assessment estimate of biomass. So you can see there's a consistent pattern of the projections.
You're not doing great.
They didn't do really bad, right?
Although it's a good direction to be. It's a good direction to be in.
Well, unless you're the industry and you're getting
Yeah.
really pissed off, saying you should have another cut because things are going to go down. It's like, wait, you said that last time before that. So I think this kind of thing becomes possible if you're willing to look at just the mean projection, not the uncertainties. These projections come with uncertainties as well, and the confidence bounds are really wide. So the same caveats apply to what you're
I'm
talking
concerned though that that's a huge step backwards for us toward the single model, ignore the uncertainty
Yeah,
paradigm.
yeah.
You know, we've worked really hard to develop a risk analysis.
Well, then it gets really hard to tell if your advice was accurate or not. Because it could always be that 10% that you made it across the road.
Yeah, although, I mean, I look at this and it doesn't seem that bad. Not going up or down. Not on every year, but mostly when the stock is going up, we're saying it's going up, and mostly when it's going down with a reasonably high probability.
Yeah.
so the first 2 years were clearly wrong. Next year, it's more right than wrong.
Having a 1 out of 4 chance that it goes up, or better, 1 out of 3 chance in 2014. I wouldn't say that's
Okay,
wrong.
let me see if
given
I'm
the
reading
data
this
that we
correctly.
have.
The projection, so the projection had 30% chance of going up,
Mhm.
70% chance of going down. So strongly favored going down.
But still a
But it
1
went
out
up.
of 3 chance of going up.
Yeah, but it's strongly favored going down. Like the prediction was that it was going down.
Yeah.
So those two incorrect. The next one, strongly
Incorrect
favored
is the
going
right
up.
word.
Directionally, yeah. So yeah, but you're if you think of it in terms of a bet, you would not have put your money on going up.
Rational better should not put their money on
No way would you do that. You would bet on the 25%, 30% one versus the 70%. Come on.
All right.
Depends on the payoff, of course, and all that, but just straight up, you're not putting your money on that. Putting your money on whichever bar is bigger. So that's what we're using as our just whether we're saying correct or incorrect. Correction.
In that context, I think there's only 4 years here where it's bigger than it's red. 4 out of what, 15 years or something.
Yeah, so generally, the model's doing pretty good. Like you're
For up or down.
favoring the
For up
outcome
or
that
down,
actually
right.
happened.
But there does seem to be a lag.
Yeah.
When there's a transition from increase to decrease or back again, it does lag a year or more. Which again, I don't think anybody's surprised about. Was worth the stock assessment policy.
And what's the one in the end? The one in the end is your projection from this model?
Right. So we projected a pretty high probability the stock would increase. We don't know yet. Find out when we get the data. And I included that for accountability purposes there so that we can see This is free
Pre-registering.
data, right?
Pre-registering your
We'll
study.
Free data. That's interesting.
Yeah. So this is based on the catch limits that they set for 2025. Models with data through the end of 2024.
Okay.
So it's the same bar as all the other years. I just don't know what the colors are because we haven't seen it unfold.
So I think, to us anyway, if there's any, I think this goes back to, in the research plan. Remember, we were trying to come up with, well, how do you measure the reliability of the
Yeah.
stock assessment?
Yep.
And this is kind of pointing at that. It's like, pretty good. As far as stock assessments go, it's directionally, it's good, and even to some degree, magnitude.
It's kind of what Lexi does.
The bar's low.
To tear that thing apart.
Sorry,
to start over.
One of our best assessments. This is multi-way.
One of our,
I wish I had more years because this, especially these first 2 years, the stock had been declining for 10 years, 12 years in a row before that. So I think what you're seeing is the tail end of that lag from. It would make more sense. So I guess what I'm hearing, and I'll look for the report as well, but what I'm hearing is that there's some useful information here. Going to need to work on some other ways to present it and describe it.
even if there's just a simple narrative you can use,
Yeah.
maybe you don't need a graph
Yeah.
or something. Maybe you
Try
could
try
say,
the ROC curve.
generally,
Yeah.
this model,
We will.
however many years that is, out of 10, it generally gets the direction, especially I think, for the, which is, statistics says that, right? The bigger the effect size,
Right.
the better it's going to be. So
Yeah, I wish I also had the ability to go back and see like 10 probability of 10% decline. Because with a
Yeah.
fairly flat stock trajectory, you see these probabilities change quite a lot, even for just that 5%. And it's pretty sensitive to just 1 or 2% here. And I don't know whether I don't know how much to make out of this one. I mean, certainly under predicting a decline of 5%, but the biggest decline we saw was only 8%. So
we used to get in arguments about this all the time. Sailfish said, because they're like, your model says it's a 4% change, like the error bars, and it's noise, measurement error. And we're talking about the median here, and this is similar. If we're talking about CVs of the survey of whatever they are, 8 to 15% is the kind of.
but the CV's out of the assessment. We've got all the structural uncertainty.
Yeah.
Well,
But it's
They're
still able
appropriately
to,
large.
still does a decent job at a 5%.
Well, essentially, the assessment is just a smoother on the survey time series.
Yeah.
And so if the survey jumps in one direction or the other, if it doesn't catch it this year, it's going to catch it next year and follow that.
But it's also the trend, right? The assessment has a lot of uncertainty in the absolute estimate, not necessarily in the trend.
Exactly. But the trend is what people have been focused on in terms of decision making. They're relating the trend to the quota this year compared to last year. That's the math that's going on, I think, generally in the decision-making process. And that's why I focused on these two quantities. These are the closest to what people are using. They're looking at last year's quota. They're looking at the probability of the stock going up or down from here. And then they're looking at this year's quota.
I must say, I like the way you present these probabilities.
I won one person over.
It took a
We all like it.
while
We
to
all
actually
probably
understand
easy on
it,
the.
but now that I understand it, it actually is quite genius way to, because it shows the trend, or like whether it predicts the trend correctly or not, but also the distribution of probability mass. Because if it's half red, half green, then like we don't really know where we are. But like the first years here, the whole probability is about 0. So the magnitude also matters, not just whether it gets the trend correct. But yeah, it's difficult to kind of, you might verbally like work out an example year, explain what everything means. Then that might open up the structure of the figure.
You can,
There's a lot going on.
can use that in your slide title, a genius approach. You better, yeah. The commission.
Yeah, I think I'll be short on that one. I do like the idea of walking through an example of 1 year. Here's what we thought, here's what happened, this is what the probability looks like, and then here's how it happened the next year and the next year. Yeah, I might be able to weave my way through that description. Let's see.
It really is pretty slow to update here. It looks like, I'm looking at that 2017, 18, 19. It's not until 2020 when it's finally like, it's more probable than not.
Right. But remember, the threshold here is 5%,
Yeah.
and the change was exactly 5%. So we're talking
Right
about
at
the
the threshold.
slice
Yeah.
on the margin there. Okay, the next one, the next one was recruitment projections. This might be the last substantive piece, so we're gonna have plenty of time this afternoon if we wanted to loop back on anything. So this was a request both for the MSE and the stock assessment to look at random walk and recruitment. I think the main concern being, are we getting an effect of just snapping back to the stock recruit function at the end of the time series when the data run out? Unfortunately, I was not able to address this quite the way I wanted to, but I'll show you what I did and we can talk about where we could go from there. So in the platform that I'm using, Stock Synthesis, we limit the projections to 3 years. And I've done this, actually, we've done this for years here at the commission. The reason that we limit our projections to 3 years instead of producing a 10 or a 15-year projection is that, well, 2 reasons. One reason is that historically there were projections, 10-year projections being made out of the stock assessment that were very much wrong and were being substantially updated every year. The second reason being that beyond 3 years, we're beginning to include what I'll call electronic fish in the projection in the spawning biomass. And the reason is because we see fish from age 5 onward. Maturity increases pretty steeply around age 8, slightly earlier with the new curve, but really about the same pattern here at age 8. And so by limiting to 3 years, what it means is that we're not going to have any recruit into the spawning biomass at a appreciable amount that we don't have any data for yet. We don't have any purely stock recruit based recruitments coming into the spawning biomass.
So your recruitment projections don't really matter much.
So they don't really matter. And that's really we cut it off at 3 years so that we're not relying on the stock recruitment curve to tell us what's going to happen in the future.
Well, it's not necessarily telling you what's going to happen in the future. What it tells you is what it is you're projecting, if it's a catch or it's a harvest rate or something, into the future, how what that is relative to the productivity of the stock that you estimated from all of your historical data.
Yes.
So it gets you out of that myopic thing that's what, if it's like, okay, you got this much recruitment coming in, and so we're gonna deal with the little ups and downs, and we're gonna micromanage this recruitment that comes in. It's all about that rather than the bigger picture of what's the productivity of the stock on average and what are we doing on average. It drives the longer term. You know what I mean? Like you could, if it's a myopic kind of recruitment based strategy, like it seems to be, you can basically go down rabbit holes a lot deeper than if you had a bigger picture where you're matching more the fishery to the average productivity.
So I think we're trying to deal with that issue with the strategic MSE. And a
Yeah,
tactical
the MSC
assessment.
stuff is a better reflection of that.
Yeah, rather than trying to do strategic projection assessment, which in my opinion is not what an assessment model is designed to do. regardless, this is what we've been doing. The technical details in the assessment framework that I'm using are that we have 3 periods of recruitment deviations. We have an early period. In this case, this is the initial age structure model estimated as recruit devs and then played forward into the numbers at age. You have a main period, and the main period is required to be zero-centered, so that if you have a stock recruit function, your productivity is actually consistent with the stock recruit function you're using, as opposed to have no meaning in the assessment. And then you have a late period where you're, again, no longer constrained to be centered on the stock recruit function, but you can see as you leave the period with data, you'll just end up back at a 0 deviation, and the variance will go to sigma R in the forecast period. This is the way the software is set up. It's set up this way on purpose so that you can maintain centering of your informed time period on the stock recruit function and allow for essentially whatever initial conditions you need and allow for the end period. The reason you need to separate off this end period is because if you fit your data a little better by not being centered on the stock recruit function and you include these deviations out here, you end up balancing those deviations. So it'll make those all positive or all negative just to fit a little better in the time series. And you'll see that in one of these models. It actually happens in one of these 3 models pretty substantially. So the challenge, though, is that I don't have any control over the recruitment deviations until the end year of the model. So these are only going to kick in at the end year of the model. But so to do different recruitment scenarios, what I did was I set up 3 different ones, and I didn't do autocorrelated recruitment. I just did a low recruitment, a recruitment right off the curve, and then a high recruitment, consistent with these time periods that we've seen over the last few years. So we've had a period of low productivity from 2006, and we've had much higher recruitment over the period 1994 to 2005 to generate some contrast so we can see the feedback. In the coastwide long model, you can see that this is the spawning biomass time series on the left and the recruitment time series on the right. You can see the difference in the central tendency. This, yeah, I guess you can read those labels a little bit.
Where are we at the end?
Yeah. So this, the red here is the 2006 to 2015 average. And the green is the 1994 to 2005 average. So there's quite a big difference in the recruitment and the average recruitment over those time periods. And you can see it if you look back in the time series itself. I mean, this period back here where you had much higher recruitment than this period from 2006 to 2015. So I used those 3, but you can see that that doesn't kick in until the end year of the model. And so it doesn't have any time to affect the stock recruit, the spawning biomass that comes out of the projection, because it's only a 3-year projection. If these projections ran out 10 years, you would start to see that feedback kicking in. Similarly, for the areas as fleets long model, it's a similar contrast. And I guess the other thing to note here is that we're not getting in the period leading up to the end of the model. So the data start to phase out after about 2019 or 2020. There's very little signal in the data about these recruitments, but we're not just jumping right up. We're not jumping back up to a stock recruit function level that is inconsistent, I don't think, with what we're seeing. So that's kind of why I plotted all 3 of these. So you can see what we're getting in these uninformed years is something that's in between the low values that we've been seeing and the high values, but a lot closer to the low values that we've been seeing.
Is that just because that's where the stock function is?
That's because that's where the stock recruit function is. Yeah. So we're not in a case where we're seeing recruitments that are so far above or below the stock recruit function that we are getting this big transition when the data fades out. The one exception being the areas as well, there's 2. So the areas as fleets short model, both the short models, you start to see a little bit of balancing. So you can see at the end of that time series there, when I force the main recruit dev to go to the end of the time period, it brings that level down, and I'll put the cursor on that. So what I'm talking about is this level here is a little bit below the blue. And what that's doing is it's basically balancing the time series with those uninformed Eves at the end there. It still isn't feeding back. Even that level, you see there's basically no feedback in this because only the very first few of these are going to mature, and even then not very much. And then the coastwide short model, you see a huge feedback, and this is exactly why that control is in there, because sometimes you get cases like this where this is essentially saying there's no recruitment after 2019. And even in that case, with effectively zero recruitment after 2019, you can see the spawning biomass isn't all that effective, even at the end of the 3-year time period. And that's because of these lags.
So few of those fish have actually matured into stock markets.
The reason why these are going to zero here is because it's balancing this period. Instead of, I've extended the main recruitment period. So it's got a bunch of parameters. It's summing to zero, but it's got a bunch that don't have any data. So it can just adjust those to fit the time series. So it's basically steepening up the stock recruit function a little. This is the model with low M. So it's doing that to steepen up the stock recruit function.
So so these are scenarios I know you're doing, but normally, would you be calculating the recruitment penalty all the way up to the end year of the model?
No, normally
You only go to the
I'd be
last-
going up until somewhere in right now, with the data I've got, somewhere around 2018 or
Yeah.
19.
Okay.
So we don't get this weird balancing stuff. But in order to use these controls, I had to extend it out. So that's why I was highlighting that. So again, there's still very little feedback to the spawning biomass, even with essentially saying, let's just say there's no recruitment after the data end, because there just isn't time for that to feed back in the 3 years. So the takeaway from this is that I'm certainly not opposed to autocorrelated recruitment, which is what the original request was, but in the context of the short-term tactical assessment, it really doesn't matter. It's more a discussion for the MSE and longer strategic projections.
One note about moving to a state-based framework is that the discussion then becomes about assumptions for the number and age random effects, how you project those out.
Yeah.
And that matters a lot. That's something we've seen
Yep.
with the Black Sea bass assessment, where depending on what you assume for the autocorrelation of the numbers and age random effects, it either snaps back to zero, or it continues with current rates. And they've been far from zero in the last couple of years. That's a huge difference in what the projections do.
Mm.
So that's a caveat for moving
so-
to state space.
All of these state-based models a lot of them are using deviations on the numbers at age. Is the assumption there that there's immigration occurring sometimes? Because you're magically creating fish between sequential ages in the middle of the time series.
You have virgin births at age 3.
Yeah.
Is there a reason why they do that?
Well, it makes sense in the terms of, I've heard it described as the negative deviations can be unmodeled mortality. But the positive, but it's always a distribution. And so the positive deviations, the best explanation I've heard is if you have a stock that's really not closed. So you have, for example, you have a US-Canada boundary, you're analyzing just the US side. You've got some fish that are maybe drifting back and forth. That I can imagine could
We
create.
have that for sablefish. I think we tried one of those,
Yeah.
those sand roaches. It's just like,
Yeah. It makes me nervous to have deviations. You can
I don't see why
you can use the random effects approach without turning that particular feature on.
you got time varying natural mortality.
Exactly, recruitment and selectivity and all the other things.
Although I think most of the applications are for an age range.
I know, especially,
And
well,
they're-
at least in New England. I don't know, in Europe as
That's
well.
why they get that.
Doing it as well.
This predates the move to WAM.
Yeah. I guess I'd have to convince myself that you shouldn't be worried about those balancing when you include deviations with no data and you have a distributional, you can keep a distributional penalty. Yeah. Anyhow,
Distribution.
it's gonna do it, yeah. So anytime you have uninformed deviations.
It's going to use those to balance it.
Right, and in a case like, we went through all this trouble to build a coastwide model, so you could say there's nothing coming in,
Yeah.
and really, you have no basis to have.
Well, maybe that's the approach then, the coastwide model, you turn, thinking into the future, you turn those off and the areas of suites models, you use those to balance.
I think it would start there for sure. I mean, we do have the potential for some exchange across the Russian. And potentially more so in the future, but as a fraction of the total stock, we're looking at less than 10% of the stock in the Bering Sea to begin with, and then only a fraction of that would actually be moving across that boundary. So we would have a fairly
Improving deviations, the aging error, all those stuff.
Which is a good segue into your next bullet, which is that I was talking with Olaf at the break. I have actually already downloaded the WAM software. I'm starting to explore that a little bit. The publication of the multi-stock version just came out, which is the one that's potentially most adaptable to having two sexes.
So what is this? This is, you get the TMB code?
It's in RTMB. You get it's all they've got it all up on GitHub, so it's all right there. So I'm learning how their stuff works. So I'll be working on that. But I haven't spent a lot of time on it and won't have a lot of time to spend on it until after this tactical assessment is done here in a month and a half. Which leads to the rest of this fall, which is that basically I think we're all comfortable with the development through June, and I haven't made any, or I don't suggest any further changes, structural changes to the models. So from here, we just go through the routine process of updating all these various data sets. And I won't read through them all, but it's the standard stuff that we update every year. New survey information, new fishery information, biological sampling, and then mortality estimates. And those all get updated and added to the model, and then that's it for this year. That's this year's stock assessment model. No further changes to the assessment structure itself. So the recommendations are to note the responses to the requests and anything else you'd like to see on those requests. I don't think we have any modifications to the assessment at this point. At least none of these avenues suggested to me a change this year. And then also maybe some thinking about what kind of development to be working on toward next June.
So you're gonna start working on this new models March, April?
Yeah, then more sooner. Once we're through the annual meeting in January, we might. I mean, I'm intending that to be the research focus this year.
If it was me, you got 3 years to do it. I would take whatever base model is they give you and just start simulating some data, looking at what the model does, what it's good at, what it's not good at. Try to address some of the issues that you guys have, discard mortality, like some of these things you can go in. It's one of the nice things about having your own model. It's like, I'm going to put in, discard mortality in this area and sample from it, whatever else, you're interested in before you dig into populating with all the halibuts. Just before you pollute your mind with real data.
I do want to spend some time just understanding what structures, what data structures are available and what are going to be needed. We have a pretty rich data set compared to most stock assessments. So I want to make sure that we're not going to have to give up too much. I mean, we're not going to have the ability to do everything we do now in a new platform, but I don't want to give up some of the post.
Well, on someone else's platform, you can do whatever you want. It's your platform.
Yeah, at
That's
this
the
point,
idea,
my
right?
intention wasn't to write a custom code. I mean, we can have that discussion some more, but I think there's some value in sticking to a broadly used and tested code base, at least as a starting. Been in both places. We had a rocky time of it when we had our own code here at the commission. Code gets stale.
That was a
and
whole different
nobody's
situation,
maintaining
though.
it. No, I know, but you know,
Well,
they're both camps are alive and well in the world of
True.
custom
Yeah.
versus platform based.
Yeah, I
Even
mean,
here, you've got the custom efficient temporal model.
Right.
And,
Yeah.
packaged,
yeah, like if
assessment
there's
platform.
any place that's gonna have a continuous maintenance of code and everything, it's here. You've got a model that be dedicated to one stock that you can do your simulation tests and everything you need to do to convince yourself it's working right. I don't know what everyone else has done to WHAM. They've done a lot of simulation work on that to see how well it does in certain situations. The whole idea of developing your own platform is to answer your own questions and for your own needs. Like, you don't have to worry about what other people are doing.
I don't know.
That's my
Yeah.
advice.
I think I fall on the other side. I mean, having other people involved in development and maintenance takes a lot of the pressure off of you. Not only doing the assessment updates, but also just keeping the code up to date. And there's zero chance that there will be new features added unless you do. On the other hand, you can have the features that are relevant for your stock rather than paying for somebody to make it a priority. Somewhere in the middle where, you're sort of integrated into the development team for WHAM and can understand the level where you're able to add new features, but you're also not the only user and so not totally responsible for the code seems to be the sweet spot.
There's a lot of parallel development going on right now as well. There's WHAM, then there's SAM, which is much more established, but has a much reduced feature set.
Exactly.
They're very specific about the types of data and things they do with that model and really don't branch out from that much. And I've had some good discussions with Anders, and he's not interested in adding 2 sexes, for example, under any circumstances. And then there's FIMS, which is the NOAA model that's been the next up and coming hot new thing for at least 6 years now. And they've have yet to see an assessment done in it. So yeah, I almost
want to have it under your control rather than.
Well, I almost feel like we're back where we were in the 90s when ADMB came out. Everybody was like, yeah, let's do it. And everybody went in different directions in ADMB. And then many of those didn't end well. And everybody pulled back toward a lot of other platforms. And now we got TMB, or even better yet, RTMB, and they're diverging again. But I don't know in the long run exactly where we're going to end up. I periodically check in with, for example, the Tuna Commission down in La Jolla, and they are fully committed to staying in stock synthesis, but interested in state-based models as we are. So
Talk to the Southern Bluefin people, and they're the opposite. They wouldn't touch it.
right.
So it just depends.
Yeah.
That's who you talk to.
Yeah. No, I know.
In the Northeast, every new assessment, every new research drawing assessment is going to WHAM.
Right.
I mean, some of it's situational, like in the Northeast, they got a zillion stocks. So makes sense. team is dedicated to one species and has the time of one species. Sign. You don't even have to answer to me. It's, you do it here. I'm not going to be here at SRB 32.
Who knows? Maybe we'll have you back just for fun.
Anyway, so it's 3:00. So we're done the stock assessment.
Yeah, we're ahead of schedule. That's it for me.
We have an hour.
Suggest you actually write, just thinking.
We can start drafting. That's what it says to do. Schedule set.
2 hours to
No.
draft that.
The first part of the MSE presentation is related to that recruitment request. That was for the assessment and the MSE. If you did want to start that, it might continue that conversation a little bit, and then we could break on the MSE once we get into the more harbor strategy policy stuff.
Yeah,
If
a good
we want to
idea.
do that.
So we scheduled to go till 4. So why don't we just do that?
Yeah, it'll be less than an hour. Yeah. Well, they're already thinking ahead. Right, excellent. Let's see. And if I, Alan, could be made presenter, that would be great. Thank you. Perfect. All right, I'll jump in then. Perfect. Okay, so the outline of this management strategy evaluation, harbor strategy policy talk is 4 major topics here. And as I said, that first one is going to be a continuation of the investigation of autocorrelation recruitment. And then we'll talk about the definitions of overfish depleted, definition of overfishing, and then an update on the process to adopt a harbor strategy policy. I think we get through this first bullet point today. That would be a nice extension to the assessment talk. So here is the SRB request, and this was for the stock assessment and management strategy evaluation. Ian showed a little bit this or just a few moments ago, showing that for the 3-year projections in the stock assessment, it didn't really have a lot of effect because it's not even coming into the spawning biomass within 3 years. But for the MSE, it could have a much bigger effect. So what we wanted to do was begin addressing this request by first just looking at autocorrelation and the estimates of recruitment deviations. Is there autocorrelation or not? And what sort of autocorrelation or time series models might explain those? And then we wanted to do simulations with and without various levels of autocorrelated recruitment deviations using the MSE operating model to see those effects. So to begin the investigation of the autocorrelation, just here's a little review of how recruitment is modeled within stock synthesis and within the operating model. And what we're going to look at here are the recruitment deviations. So it's using the average recruitment, R0 in this case, and noting that R0 is adjusted by the PDO relationship. So we have this, what we're calling a low regime and a high regime. And then with that modified R0 potentially and the stock recruit curve, there's a deviation applied, which is a log normal. And that's shown by the recruitment deviation here, the epsilon y. And what we're going to look at is the autocorrelation and the actual deviations. So I point out this PDO relationship because in a sense, modeling this with the PDO relationship is already bringing in at least some autocorrelation in the average recruitment. So if current conditions are low, they're likely to remain low for the next little while as the projections go. And the way that the MSE handles the modeling of the PDO, it's basically a probabilistic switch from low to high or high to low, that the probability increases the longer the run is. So the way that you can see this in this plot on the bottom right here is you see in the past, it is a PDO is high or the PDO is low because we've actually observed those data. Once we start projecting right at this point, well, actually it's probably a little tiny bit before, it has that probability of switching depending on runtime. And so as time progresses, the probability that the PDO is either high or low will increase for a while, and then it sort of stabilizes over the long term. But the point here is that in the short term, there's still some effect of previous years that are coming into the average recruitment. So I think that this modeling method tries to get at a little bit of predicting what might happen with average recruitment in the near term. And I think that's addressing that request a little bit, but not completely. And what you'll notice is that, well, this is about 15, 20 years out, there's actually a high probability that it has switched, which we've seen in the PDO. It's a decadal oscillation. So we think about 20 years, it should be switching to the other one. Whether or not that would happen is another case. All right, so that is the sort of background to the modeling of the recruitment. And now let's take a look at those actual deviations. So in the document, I present more than what I'll present to you today. I present this sort of look for all the four models in the ensemble from the stock assessment. And this is using the 2024 stock assessment. And I've plotted out, oh, just switched, I guess. So I've plotted out on the top left from the AAF long, the actual deviations in, what's that?
You're not moving the foot.
No, that's all right. But this plot up here is showing those deviations from the stock assessment model itself. And so you see that the line there, that horizontal line is centered on 0, and it's a deviation from the average recruitment. Noting that average recruitment is also changing. So it'd be interesting to figure out a way to plot that. And what you can see is that early on, well, you see the error bars on there as well, but you see early on, there's maybe some autocorrelation, but then there's sort of these trends in there. There's some years that do switch quite rapidly between them. And you see in this period here around 1990s and the early 2000s is probably some of the best estimated period of recruitment. So we then take the main period, which are the bold dots, as Ian explained earlier, you have the early, main, and late periods of recruitment. We're only looking at the main period because that's when we believe recruitment's actually informed by data. And we take that main period and we just do an ACF plot of autocorrelation. And you see it, I can't remember how it determines a level of significance with the dashed lines, but you see it's saying, yeah, it looks like there is some autocorrelation in the deviates, at least up to lag 4. And so it's saying potentially there is. So that's interesting. And the SRB request also stated to take a look at a random walk. So what we did is convert those deviates to a random walk by just subtracting the previous one from the subsequent one and see what that looks like. And what that does is it reduces the autocorrelation, but makes it have actually a negative autocorrelation at lag. So, and you can see that in the comparison of the two plots on top there. The deviates seem to have smooth changes where the random walk seems to be sort of oscillating from year to year. So that's the graphical representation. We present the results from all 4 models in the document. But what we wanted to do was to actually run these through some ARIMA models and see what the statistics thought about this. And is it possible to use an ARIMA model to predict the next year's recruitment? And so we have in the first 2 columns over on the left, AA long and CW long, that's using all of the years from the main periods. And what this table is showing is each row is a different type of model, and it's showing the AIC from each of these different models, so we can basically do model selection. The columns are the different models, but we've summarized that the 4 on the right, all using the same period of years. So we have an AAF long and a CW long over on the far right, which uses a subset of the years. And that was to just say, what do these models say in the most well-informed period of estimated recruitments? So the blue shaded areas are showing the lowest AICs that are within 3 units of the lowest AIC in this analysis. And so you can see when you use the entire time series, it's suggesting a REMA model with either a 3 or a 4 year lag, or using 3 to 4 of the previous recruitments to predict the next recruitment deviation. When you take a subset of the most recent years, it's suggesting that there is not a model much different than the null model without correlation on it or a time series on it. So part of my thinking on this was, well, those early years are not well informed, so it might just be some introduced autocorrelation there. There's aging error, there's all sorts of different errors that could include that, but there is some evidence that perhaps there is a lag or some sort of predictability in these more recent recruitments as well.
Only 4 years is just a pretty short time to put
Yeah.
remote models.
Yeah, it is. And I think it shows that as well. But I think what's interesting too is using the random walk specification of this. Can't remember what the different numbers stand for, but the 010 is basically a random walk, a differencing, and it really has no support based on an AIC. It didn't explain it well at all. That doesn't mean I'm going to give up on this. So what I thought next was, okay, that's interesting. There may or may not be some autocorrelation in the deviations of recruitment. But now let's take this question at a slightly different angle, and let's ask ourselves, if there was autocorrelation, would that have a big effect on our results? And so we ran 3 different sets of MSE simulations. The top one here is without autocorrelation. So it's just a set of deviates simulated into the future from a log normal. And you see each one of these has a same random seed, so you can do a little bit of a comparison. And you see the ACF plot, if you can read that, it's showing no autocorrelation, no significant autocorrelation in this one simple set of deviations, one projection. We took the best AR model, the AR4 model from the AAF long that was presented earlier, and we used actually the parameterization of that model, which is shown here. So it's predicting, it's interesting, it's predicting a stronger covariate for the lag 1 and the lag 3 than the lag 2. But nevertheless, we just decided to use that AR4 model. And when you project out a time series of deviates from there, you see there's slight autocorrelation shown in the middle there. And then the last one, we actually put in autocorrelation specifically with this function there. And we just assumed an autocorrelation of 0.5. And you can see that set of deviates as well. And that the ACF plot shows that it does have an autocorrelation about 0.5. We ran those under one SPR value, and we get these results for the 4 sort of priority performance metrics from the MSE. Now, I should have marked it on this plot, but the first 2 rows, the probabilities of the relative spawning biomass, both of those are long-term performance metrics. So they're calculated think 50 years into the simulator. Actually, these are calculated 60 to 70 years into the simulations. So the autocorrelations had a long time to come in. The PDOs had time to stabilize, and those are the results. The bottom two rows are actually short-term statistics, so that's 4 to 13 years into the projection period. So they're going to be more affected by more recent happenings and modeling of the PDO and other things like that. And then the columns are the different autocorrelation scenarios. And what you can see is that the two autocorrelated series have slightly different results. So it does result in slightly different simulation results. This does have an effect, a higher probability of going to lower biomasses shown in the first two rows, and a slightly smaller TCEY with a higher average annual variability. In hindsight, we probably should have ran these for different management procedures to see if it was picking a different management procedure. And by the time I realized that a couple of weeks ago, I was like, I just don't have time to get all that done. So that would be a nice extension to this. So the last bullet point there says, we do not know if this would actually result in choosing a different management procedure. And I think that's the important question to get at here. So is that the end of that? Oh, yeah. So I have a few conclusions. There's slight evidence of autocorrelation in the estimated deviates, but it could result from other things such as uncertainty and aging error. As Ian presented earlier, the 3-year stock assessment projections are not affected by how recruitment is projected, but the short and long-term MSE metrics are slightly affected, and it's unlikely. I don't think it's going to result in the choosing of a different management procedure, but I can't say whether or not that's the case, because it's really going to be that trade-off between yield and variability. But it's something that we can certainly test. And did I have anything else to say about this? I think that's it. Yeah. So that's it for the recruitment projections that we've done. So,
Thanks for doing that.
yeah.
You know, I think it seems to be about the right magnitude you'd expect. Because you said year 4 to 13.
Mhm.
Is that what you're averaging those over? So it's kind of right in that ballpark of when and if you're starting your recruitment like 8 years ago.
Yeah. Yeah. Well, you see the recruits coming in at age 8 into the spawning biomass. They start picking up. And so, yeah, that 4 to 13 is right when your projections should start seeing those electronic fish.
So it is having, it's not a massive effect.
Mhm. Yeah, 2 million. And it's interesting that the AR4, which didn't have as much correlation as the 0.5, were similar. And I'm wondering if just autocorrelation in general causes this result. The magnitude of it might not have as big of an effect. But yeah,
Because you're coming from lower, so that's the effect, right? It's saying you're not going to snap back to just what the uncorrelated does.
it snaps back to average recruitment, which average is controlled by the PDO.
Right. But they're all controlled.
Yeah.
So it's representing that lag a little bit.
I think so. And so the other question, so the question is, would this result in choosing a different management procedure? And it probably depends on the management procedure. But the other question is, what is a reasonable magnitude of autocorrelation to include? So I've shown you the analysis we've done, but I chose the 0.5 sort of arbitrarily at this point. Let's look at a better value for autocorrelation in this.
Well, it looks like you don't have to worry too much. I mean, the AR4 is probably safer because you fit it to your data and forget about it.
All right, well, that's all that I have on that. The rest of it's for the harvest strategy policy. That might be more.
I'll have to sleep and get some rest
Yeah,
when that one comes out.
yeah. Yeah, me too.
Depleted and overfished. Straight.
Yeah.
Hopefully it'll be straight up to the whiskey bar.
So do you guys need tech support? So Ready? For
Yeah, because, oh, the one's still plugged into the wall. I
Sure,
thought you
sure.
used that
We
one
should
last
be
time.
able to.
Maybe the meeting.
Oh, yeah,
we should-
which we'll have to,
I think Sean just needs to announce it.
So anybody that's participating, we're going to sign off and then we'll be back tomorrow morning. Pick it back up at 9 o'clock tomorrow morning.
yeah, and I think the secretariat can close the meeting now. Because you want to.
This one's right. That's right.
Can't say, shut it down.
Shut it down.